Mostly we've been working with understanding concepts. Now we're going to start to apply that. We're going to start doing what's called combining like terms. And we're going to do that for expressions. So one technique is to use a model. And for modeling we are using Algebra Tiles. We have a polynomial here. It's got 4 terms, but they're like terms in there. So if we were to draw the Algebra Tiles to show each term, we'd have 4 x's, which is 4 dark bars. We'd have 2 negative x bars. We've got 3 single shaded tiles for the 3, and then we've got 6 single white tiles here as well. Now remember, shaded means they're positive, white means negative. The little guys are worth 1, the big ones are worth x squared, and then the bars are worth just an x value. So 0 pairs is an important concept, and when you add a positive and a negative together, they create what's called a 0 pair. Plus 1, and then if you add a negative 1, they cancel each other out, and if you add them together you get 0. Same with the x squared and the minus x squared. You add them together you get 0. Same with the x and the y. If you add, or the negative, sorry, x and negative x. If you add them together, you get 0. So they're called 0 pairs because they cancel each other out. So if you draw this out, you can then create groups of 0 pairs that wipe each other clean. So in this example, we've got 2 whites and 4 blacks in the x category. So we can take 2 of each, and those are 2 0 pairs, and they get pulled out of the workspace. Same with the 1s. We've got 3 shaded and 6 unshaded, so we can take 3 of each and pull those out as 0 pairs as well. Once we do that, we are left with 2 x bars and then 3 little negative x's, or negative 1s I should say. So that's what's left once you remove your 0 pairs. Once you do that, then you can reassess, well, what polynomial is this? So there are 2 positive x tiles and 3 negative 1 tiles, which means the expression for the remaining tiles is 2x minus 3, which means that the original expression 4x minus 2x plus 3 minus 6 is actually equal to 2x minus 3. So this is a way to combine like terms. Now if you look at this, we don't have like terms anymore. We've simplified the expression. That's what we call it, simplifying the expression by combining like terms. So now we've got 2 terms, one with an x variable, one that's a constant. Another example. This is a little more involved. 2x squared plus 3x minus 1 plus x squared minus 4x minus 2. So there's 6 terms there. But let's draw them out. We've got 2x squared, so we've got 2 large x ones. We've got a 3x. Oh, actually, the way we're doing this, we're just identifying what each one is. So x squared, that's 2 of them. 3 x bars. We have a negative 1. We've got another x squared. 4 negative x's, so 1, 2, 3, 4, negative x, negative x, negative x, and negative x, and then negative 2. So these tiles are all of the tiles needed to represent this 6-term polynomial. But we can, this is all kind of spread out and not very pretty. We can clean it up and move tiles around to group them. So we've got all of our x squareds together now. We've got our dark shaded x bars together along with the hollowed out x bars all put next to that. And then our single tiles as well here, all gathered together. Once you gather them up, it's much easier to see your 0 pairs. So we've got 3 zero pairs formed here with 3 shaded and 3 unshaded, so we can pull those out. And that's it we have for 0 pairs. So we can draw the remaining tiles. And this is where you need to be clean about what you're drawing. You need to be able to differentiate between the different styles of tiles. So these guys are actually shaded, and the rest of them, the X and the 1s, are actually hollow. So we've got 3 positive X squared tiles, 1 negative X tile, and 3 negative 1 tiles. That's what we've drawn here after we've removed our 0 pairs from the original situation. So we can write an expression for the remaining tiles. We've got 3 positive X squared tiles, so that's 3X squared. 1 negative X tile, so that's a negative 1X, or just negative X. And then we've got 3 negative 1 tiles. So in the end, that 6-term expression, that polynomial, can be simplified by combining like terms, and it turns into 3x squared minus x minus 3. Little literacy link on the side here. If the coefficient of a variable is 1, you can write it without the 1. For example, positive 1x can be written as just x. We've talked about that. Coefficients without a sign are positive. If the coefficient is negative 1, you must keep the sign, so it has to stay negative. So you would write negative x instead of negative 1x. It's just another convention that simplifies the amount of ink you need to put down on a paper, or pencil in most cases in math class. Alright, part C. Again, another 6 terms. 4, so that's there. A negative x squared. 2x, negative 5. 3x squared, negative 2x. So that's drawing them as you see them from left to right in the original polynomial. Now we can group them into similar shapes and sizes. So we've got our x squareds first, 3 shaded, 1 not. Then we've got our x bars, 2 of each. And then all of our single 1 tiles, we've got 4 shaded and 5 unshaded. So then we can look at our 0 pairs. We've got a 0 pair in the x squared category. We've got 2 in the x category, and then there's 4 1 tiles that we can create 0 pairs with and pull those out. So the remaining is 2x squareds. There are no x tiles left, and then there's one tiny little one left here, and then again these are shaded. So that long 6-term polynomial gets reduced down to 2 different types of tiles. So there are 2 positive x squared tiles and 1 negative 1 tile. So the new expression is now 2x squared minus 1. So just rewriting that one last time. This last polynomial with 6 terms can be simplified down to 2 terms when you combine like terms. Now, method 2, using symbols. You don't necessarily have to draw it. Here's an example, 4x minus 2x plus 3 minus 6. You can add or subtract the coefficients of the like terms. So again, the coefficient is the number that sits before the variable. So in this case, we've got 2 terms here that are like terms because they have an x with a 1 coefficient, and 2 terms here that are like terms because they're constants. So if you look at the coefficients, we've got a 4 on this one and a negative 2 on this one. 4 plus negative 2 equals positive 2. So those 2 terms can be combined to create 2x. You're going to keep the same variables with exponents. You're just combining the coefficients. So 4 plus negative 2 is 2, so you have 2x. Just like if you take 3 and subtract 6, you're going to have negative 3. If there was a variable attached to these, you would do the same thing, and then you would tack your variable on afterwards. But in this case, they're just constants, so there's no variable. So this 4-term polynomial can be reduced down to 2x minus 3. A couple more examples here for you. We've got another 6-term polynomial, and they want us to rearrange the terms in the expression so that the like terms are beside each other. The way this is written, we've got an x squared here, and then there's an x squared way over here, an x here, an x way over here, constant in the middle, and then at the end. So we're going to rearrange them so that our like terms are together. So we take the original one. We've circled the x squareds, we've boxed our x's, and then the constants we've just left untouched. So 2x squared plus x squared. You can do this. Rearranging is fine. As long as they're being arranged correctly with the right addition or subtraction between them, then you're good. So 2x squared plus x squared can be written here. And 2 plus 1 for your coefficients leaves you with 3x squareds. Now let's take a look at the boxes, the x's. We can rewrite it so that it's plus 3x minus 4x. Look at the coefficients. 3 minus 4 gives you a negative 1, so it becomes negative x. And then let's look at our constants. Minus 1, minus 2. So negative 1, subtract 2, gives you negative 3. So then the 6 terms reduces down, simplifies to 3 terms. 3x squared minus x minus 3. Hopefully you can see the maze that's sort of created here with all these lines. So another example here, 6 terms. Here's the original. We're going to group our x squareds together. And there may be different strategies on how you do that. You might look for something with a high degree to start off with. So x squared is a good one to start with. We've got a negative x squared, and I'm just going to cross them off as I rewrite them here in groups. So I've got negative x squared that I wrote down. Then the other x squareds are here. There's a 3x squared, so I'm going to cross that off when I write that down here next to this one. I'm out of x squared, so now let's look at the x's. And I start left to right. Okay, there's a 2x, so I'm going to write that down here. A minus 2x, so minus 2x. I'll cross that one off because then I know it's done. Now I'm out of variables, so I'm going to go to my constants. 4 is done first, and then I scan through. I've got a negative 5 here, so subtract 5. Cross that one off. All of my terms have been crossed off. It's been now regrouped. X squareds, x's, and constants. So now I can look at them and I can combine them. Negative 1 plus 3, well, that becomes 2x squared. 2x minus 2x, well, that just becomes 0x. 2 minus 2 is 0. And then my constants, 4, subtract 5, that gives me a negative 1. So now that I've got this, I can rewrite it a little bit cleaner again, because I've got a 0 here. So it becomes 2x squared. Don't have to worry about the x, minus 1. So 2x squared minus 1. And that's your solution for that one. So this is going to take some practice, but now you have that opportunity with a show you know. Give it a go.